what can happen. Yeah, Faith, go ahead.
Okay, especially with GP is so frustrating because the line in the middle is, you might as well be on.
Yeah, I know, and the middle is somewhat arbitrary. I mean, there's a lot of problems with turning qualitative data into quantitative. I mean, yeah, it's fraught with issues. My deal is, okay, it's fraught with issues, but let's deal with the issues in a different way. They're not going to change the system for me. I'll change me for the system, and we'll see what happens. And they work. What's great is they never look at medians, so I do. Take that. All right, let's get back into this. I don't know if you care about this. This is what historically the number of keys has looked like in my classes as I've tracked the data. Notice the curve looks a hell of a lot like your guys' curve, doesn't it? There's less tail on your guys' curve. That hopefully makes sense. I've had the opportunity to ask about 1,000, 1,500 students. One kid actually had, I believe it was 29 keys one day. You catch that one way over there? It was amazing. I heard them fall out of his bag as he counted them. It took him a couple minutes. It was awesome. So, but you see how this is the idea of representative sampling of data. You see how the overlying shape of the curve kind of looks like the overlying shape of your curve. This is an example of a curve I wouldn't want to take an average of. Why? You see, this guy down here, granted there's only one of them, and it's going to have a minimal effect over 1,000, but it's still what we call an outlier. And the averages are going to chase those outliers. So what I want to spend the next few moments doing up till break is discussing by sight, by visual, what kind of measures of center we should use. Are we feeling pretty good about how to calculate averages, medians, modes, whether we have raw data or whether we have group data? Feeling pretty good? T-tables or without T-tables? Good. Knowing how to do something is very important. Knowing when to do something, in my opinion, is more important, right? Just because you can do something doesn't mean you should do something. And that's what I think a lot of textbooks kind of ignore. So we'll make this part of the textbook. Here is a random selection of 100 American men and their LDL levels. This kind of data is easy to get from the CDC. It's kind of fun. And you can track this stuff down. All right. So, first of all, make sure you know what you're looking at. What's LDL?
Low density of lipoprotein.
Low density lipid. It's the good stuff, right? Most of the bad stuff. You don't want this.
HDL is the good stuff.
HDL is the good stuff. I'm going to make sure I say this right. LDL is the one you can have quite a bit of control over. Diet, exercise. HDL is not. Is that correct?
Yeah.
You're pretty much stuck with HDL. Yeah, okay. So LDL, you want to have less of this and more, and I'm going to let less and more be defined by the medical professionals. So clearly, somebody on this end probably is going to be classified as a better cholesterol level than somebody on this end. Lower to higher. Okay? And these are usually measured milligrams per deciliter. Is that correct? The unit that's usually used? Yeah, I get mine tested every year. I like to track my data. So take a look at the units. This bar, below 3.25. This bar, between 3.25, 3.75. 375, 425. 425, 475. 475, 5.25, and so forth and so on. So they're in half milligram increments per deciliter. Okay, with what you're looking at there? Okay? If you had to describe what that data set looked like, what are some words you would use?
Pyramid.
Say that again.
Pyramid.
Pyramid. Love it, Trinity. Thank you. Pyramid. Looks pyramidal. Very, very good. Very, very good. Other words? Bell-shaped, bell-curved. Yeah. It actually has a bit of that kind of, pyramidal, definitely. Bell-curvy. That's not perfect, though, is it? It's not perfectly pyramidal or bell-curved. Looks like there's a little bit more on this side than this side, maybe. And that happens, random fluctuations, as you saw with the data we just saw with the Excel spreadsheet. What do you call it, pyramidal or bell-curved or some other variation of that? Do you see how there's like a symmetry line? If you were to take like a marker and just go like that, it roughly divides the data. There's about half of the data is above that, about half the data is below. Good, 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 good. All right. Ask some questions. Let's identify the measures of center in this data. You pick any one you want and tell me what it is. And again, it's not raw data, right? It's not raw data, so you can't get exact. But pick one of them and tell me what you think it is. Some of them are very quick to get from grouped data like this. Who's feeling brave? You guys can totally do this. Trinity, be brave.
5.
5. Which one are you doing? Mean, median, or mode?
Median.
Median. I think that's a great idea. Trinity, how did you come up with 5?
4.75.
So the first thing Trinity said is, okay, this says 3.25 to 3.75. We're going to call all of those what? Be brave. I'm hearing it. Don't whisper it. Say it out loud. 3.5. That was a little bit louder. 3.5. Right? We picked the middle of each of the bars. 3.5, 4, 4.5, 5. Remember the drill? We do that because that's the least error-prone estimate. I know it gets goofy down here below 3.25. Technically, I guess you'd have to go between 0 and 3.25 and call it 1.6 or something like that. Don't worry about that. It's at the end anyway. And this one above 6.75 is tricky. Yeah, well, I mean, what's the highest you can have? I mean, is there a highest limit?
Infinite.
I'd technically be dead, I would imagine.
Exactly.
You would just you'd be laying on the ground dead. But don't worry about those. Worry about the ones you have data for. So, Trinity says this bar here is 5. Why would that be the median? And not just Trinity. I'm going to pick on all of you. Faith.
It's the middle of the middle.
It is, isn't it now? If you think about what we just discussed, if you draw a line here, there's roughly the same number of data on that side as on this side. Can we do our chop on this?
Yeah.
Let's chop. Sorry, Randall, I'm going to erase some part of it. Okay. Here we go. He's gone. That looks like 1, I think, right? It's about 1. Let's just cross both of those off. I just crossed the 2 lowest numbers out. I got to cross the 2 highest numbers out, right? That looks like 3, or that's like 3, I think. So I'm going to cross the 2 to balance that one. Now I'm going to cross 1 more. That means I got to take one of these off now too, don't I? So let's take that top one off there. Now looking at what remains, this looks like I got 10 more in here, yeah? See, it looks like it's about 11. That's 10. Looks like it might be up there at 11. I'm going to cross all the remaining 10 of those off. That means I got to cross 10 more off the top to balance. See what I'm doing? I'm crossing the extremes off, working towards the middle. Trinity, go ahead.
How do you know it's 10?
Well, the scale over, you can't really see anymore because I put the screen up.
Oh, okay.
The frequency, and that, you better label those on graphs. I will turn this car around. That's a good question, Trinity. Thank you, sister. You can also do it by relative size. As long as the graph is drawn proportionally, this bar is about the same as that bar, so we're crossing off equal areas. Now, I am short 1 here, but do you see what's about to happen? Do you see how by the time we get done crossing these bars off, all left is going to be in this bar? By the time we get done crossing these off, I know they're off by a little bit. This one's a little bit lower than that one. So when we cross all of these off and all of these off, we're going to have to cross some off the top and some off of this. But we're going to end up in this bar with room left to cross, which means the median's in that bar. Does that make sense? So there's a mathematical justification for the 5. The median's at 5 because there's the same amount of data to the right as there is to the left. So we call it 5. Median's 5. Love that answer. David, go.
No, I was just curious. So the numbers on the left column are the number of men.
Number of men. Thank you. This is good. I'm sorry, and I apologize for taking this for granted. It's very early. I shouldn't have done this. This is the number of men in each of those groups. So there was one guy that had an LDL below 3.25. One dude who had an LDL from 3.25 to 3.75. Looks like about 11 dudes that had LDLs between these. I'm sorry, I should have made that clear. Thank you guys for asking. I always just kind of blow through that. We're still learning how to read these graphs, so it's good to reiterate that. Good. Fair? Median's 5. Randall.
In theory,
In theory.
could you add up all the numbers, cut it in half, and just keep crossing up until you hit
Absolutely. Absolutely. But the beautiful thing is you can do it from the curve. I mean, that's the thing. What Randall's saying is, this bar appears to be about 32 high. You could put the number 5 32 times. And you could put the number 5.5 about 23 times. And put them all in order, then until you get down to the 2 middles. But we just did that on the graph without having to write the numbers out. That's kind of the efficiency of it. Fair? Believable. Hopefully. Maybe. Ish. How about mode? What's the mode?
Is that 5 as well?
A couple votes for 5? I heard 5 for 5. Justify, please. Justify why it's 5.
It's big.
Joanne!
It looks like there's a lot of 5s.
Going by the definition of the most frequently occurring data point, it's the highest bar. The mode is the easiest thing to recognize on a graph like this because it's the highest bar. It's the highest bar. Beautiful. So I'm going to call it 5. Median's 5, mode's 5. What's the average? Now. Why are you all laughing? Because I said now. Now. What's the average? It gets a little more annoying if we have to calculate it, doesn't it? Because what we're going to have to do if we have to calculate this?
Add them all up.
We're going to have to figure out, first of all, this is whatever it is. That's 3.54, 4.55, 5.56, 6.5, whatever. That's the x column. Then we've got to go over to the f column, right, and put the frequencies in, and then do the x times s, and you can totally do that. But the reason I don't want you to do that is because there's another reason. I'm giving you a hint right now. There's a really cool way of approximating where the average is when you have a data set graph like this. Imagine where your finger would have to go to balance it if that were like a plate of cookies.
5.
If this were a plate of cookies all on a tray and you had to balance it either on a hand or with your finger, if you're feeling more saucy, where would you have to put your finger to balance it? Would you balance it here?
No.
Would you balance it here?
No.
I'm going to keep moving, you tell me where to stop.
Like that?
Wait.
Go for stop.
Okay, so I had 2 votes for 2 stops, double stops. Either of these? Is that okay? You can say even further, Randall?
Say right
A
now.
little bit.
A little bit further, maybe here?
No.
No. There.
No.
No.
Oh, that's too much.
Now, hang on now, hang on. If we average all of your stops, including Randall's, we're going to be somewhere about here, I'm guessing. Now, I think that's a legit thing to say because there is a little more meat on this bar. There's also those guys out here, though. So I think it's fair to say it's right about in here. And no matter where you land in here, what are you going to call it anyway?
5.
You're going to call it 5, right? You're going to call it 5. So the mean's 5, the median's 5, the mode's 5. And if you calculate them all out, you'll see that they're all either exactly or damn close to that. When you have what's called, symmetric, unique modal data, use whatever one you want. Because they're all going to be the same anyway. When you've got this pyramidal or bell-shaped or just generally symmetric data, use whatever you want. It doesn't matter what you use because they're all going to be the same. And when I say the same, I mean statistically the same. They might not be exactly the same to hundredths place, but they're arguably numerically equivalent. So yeah, have at it. Whatever one's easiest to find, because it doesn't matter, you're going to get them for free anyway. There you go. The balance trick is one of my favorite things. I tried building a scale on my son's Lego sets, but it doesn't work, unfortunately. A, I always break them moving the class, number one. And B, there's some physics stuff that I haven't quite figured out yet. So just imagine it was a plate of cookies. Imagine it's a plate of cookies, where you'd have to put your finger or your hand to balance it the most comfortably. And that's where the average is going to be. The average is a balance point. Now think about why that makes sense, based on what David said about what the average was earlier. Or was it Randall? Somebody said about the spreading out, it was Randall. You said the equalization of the data. It's equalized. It's balanced that way. Every single data point gets a balanced amount. That's what your finger does. Pretty badass, huh? That tells you what the balanced amount is. So this guy over here, you got great LDL. Too bad, we're going to donate some of this guy's crappy LDL to you. Right? This guy here, fantastic LDL. Too bad, we're going to donate some of his crappy LDL to you. And then eventually, everybody has a 5. Everybody's got a 5. Please,
So
Trinity.
you're saying for graphs like that, the mean median mode is always going to be.
Yes, ma'am. They're going to be arguably the same. So use whatever one's easiest to find, because they're the same anyway. Cool? Excellent. Let's take our 5. We're just about at that time, yes? Yes.